Hello, everyone. Today we are solving a complex, unfamiliar question. Topic is exponential functions and the area between curves. So let's have a look at the question. So let's have a look at the question. There's two functions. So first function is in exponential function. And next one is also exponential. So we got condition is m must be more than n, and n is positive even integer, and n is positive odd integer. And also we got, so we need to show also x is between -1 and +1, but we need to show this, so the second function is greater than this first function. So, okay, let's try to solve this. So I'm going to write down, okay, so we say, so in order to, so let's say if we want to solve this greater than this, let's have analyzing. So we say because x is less than 1, so between -1 and a +1, x obviously not equal to 0. So therefore, so we will say if we're going to prove x to the power of this greater than this, so we must prove, so what we're going to do is we must prove the m plus 2 divided by n plus 2 is less than m. So we need the index numbers the other way around. So in order to, because x is smaller than, so it's between positive, -1 and +1. So therefore we need to prove. So our ultimate goal is prove this. All right, so to achieve that, so let's have a look. So let's have a look at how we go. So this is analyzing, so bracket, sorry. All right, put a bracket back on. So let's do that. So how do we start? So let's do it because let's prove this is the function we need to prove because we know m is more than greater than n. So therefore we can say 2m must be greater than 2n times by 2 both sides because m both positive. So now we're also going to both end, we're going to plus something. We're going to times by plus m times by n. Must be also greater than. All right, so now we will take the left-hand side common factor out. And then is right-hand side, we take an n, come out. So you can see I got the m plus 2, and m isolated. So now I'm going to change over. So therefore, m divided by n must be more than m plus 2 divided by n plus 2. So that's same thing as n plus 2 divided by n plus 2 is less than. So that's it. So we prove that's this inequality. So that also we said before, we said because x belongs to -1 according to our condition, or x also belongs to 0 and 1. So therefore, our equation will be proved. So therefore, m plus 2 divided by m plus 2, because that's a smaller, so it must be greater than x to the power of m divided by n. So that's it. We proved the first question. So let's move on to question B. So we need to find the area of the region bounded by those two equations. So let's put the two equations into like a fx. So let's say first function we call fx. So we're going to put it into a function format. And gx, we do x to the power of m plus 2 divided by m plus 2. So now let's have a look at, so we have a, so if I look at the fx, so we can see fx is 1 over n. So if I put a m outside the bracket and gx, I'll do the same. So you can see those two fgx both, we have a index form like exponential function. So let's have a look at m. So m is, because m is positive integer, so we could belong to z, as well as the m is even number. So it means m must be 2 times by a k. So k, obviously k is integer as well. So so therefore m plus 2 are the same. So will be positive integer as well as the even number. So m plus 2 also is 2 times by k. So therefore, okay, so therefore we have see this is a even number and this is also even index. So therefore there's two functions. So therefore fx and gx both are even functions. What do you mean by even functions? So which means if I put a negative x will be equal to positive. So if I put a negative x on the left, so it'll be same as on the right. So therefore the same. So those two functions are even. So therefore, if I'm going to find the area between two curves, so now we also know, so therefore so we know our gx, so we know gx is greater than, so remember we from question A, from gx is more than fx. So therefore the area between the two curves, so the area between the two curves, so we can use in the boundary, so we need from a -1 to +0, and we need to put a gx in the front. And plus, the other one is from 0 to +1. So because those two functions are even, so therefore those two areas are exactly the same. So those two areas be equal. So both sections will be equal. So therefore I'm going to use double of from 0 to 1. So don't worry about negative side, because the negative side is the same as the positive side, because they are even functions. All right, so now we simplify to that, then we substitute. So let's substitute into our equation. So I'm going to move to next page. All right, so there will be, so therefore a equal to 2 from 0 to 1. So let's put a gx, which is x to the power of m plus 2 divided by n plus 2 minus x to the power of m divided by n. Okay, let's the index. So we're solving for exponential function. So we will be 2 brackets. So first we need to use the x to the power of m plus 2 divided by n plus 2 plus 1 and divided by m plus 2 divided by m plus 2 plus 1. So that's the index exponential function where you integrate it. Same as the second one, so the x to the power of plus 1 plus 1 and from 0 to 1. All right, let's simplify it, substitute in 1 into the equation. Now 0 will be easy, so 0 be finished, be 0. So first we substitute into 1 into the left-hand side, so this one become 1 top. The bottom is m plus 2 plus 1, and next one will be 1. All right, now it's a lot simpler. 0 is just 0. So we will simplify again. So we're going to use common denominator. Common denominator again. 1. Then flip on the top. It's patient game, is it? So just need to one step at a time. So when you see those fraction compound fractions, so we just flip on top. M plus 2, so m plus n plus 4, and that one will be m plus n. Flip on top, n. Now we still haven't finished yet because we want to simplify this bracket. So the area in terms of mn is almost there. So let's do one more simplification. We're going to do a common denominator. So we'll make a bracket. All right, so the bottom number and then the top n, apologize. Just all right, so just make sure we don't make any mistake here. Okay, so we times by that, and then n times by m plus n plus 4. All right, now we continue on. So be equal. Bottom, copy down. And top expanding brackets. So n times by m plus 2m plus 2. So then n squared plus 2n again minus nm minus n squared minus 4n. So equal. It's very long, isn't it? So m plus n, sorry, this is n. All right, now on top we can see obviously there are things we can cancel it out, and n squared we cancel with n squared. So now we have 2m left, 2m, and 2n minus 4n is negative 2n. So therefore the final will be 4m minus n divided by m plus n plus 4 bracket m plus n. So this is the area between the two curves in terms of m and n. Okay, so now we've done the question number 2. So now we're going to show how we show when n approach to infinity, and the area, this is the area. So this is the area between the two curves also approach to 0. So n getting bigger and the area getting smaller. So let's prove that. So we say, okay, because a is 4m minus n divided by m plus n plus 4. So now what I'll do is I'm going to try to say, okay, because area is this formula, I'm going to say less, I'm going to change the top. Instead of m minus n, I change to m plus n. Now because, m minus n, because n is a positive integer, so it must be less than m plus n, so which is common sense, is that m take away n is must be less than, so therefore the top number change to m plus n and this whole fraction will be less. So this is strategy is very clever. Can you see when I change to m plus n, so those two can cancel out. So the answer will be 4. So our a is less than this. Now because we know m is greater than n from the condition. So when n approach to infinity, because m is larger than n, so m must be also approach to infinity. So therefore, m plus n plus 4 must be also approach to infinity. So the bottom number approach infinity, the total fraction will be approached to 0. So that's it. We prove the final question C. So that's my answers for all 3 questions. Thank you for watching and see you next time. Bye.